So one of the main focuses for our lesson today is on equivalent expressions. And so the name of this activity is identifying equivalent expressions. So if we're going to be looking for equivalent expressions, it would help if we would review what that even means. Okay, so equivalent expressions let's write this down. Equivalent expressions are expressions that would equal the same thing for any variable value. Okay, so we'll see what this means in a second. Okay, so here we have a list of 10 different expressions, and down below we have 4 different boxes, equivalent group 1, 2, 3, and 4. So these 10 expressions, within them, you could actually group some of them because some of them are equivalent, meaning they would give you the same answer if you plugged in a number for the letter A. So go ahead, if you feel confident that you can complete this on your own, why don't you pause the video right now and try and find those 4 equal groups and put them in the boxes. Okay, so let's start with number 1. Okay, so number 1 says A plus 3. So I'll just put that one in the first box. Okay. All right. Now, I have to find one that would go with it. So looking down, I think 10 would actually go with it. 3 plus A and A plus 3. So to review, this is called the commutative property of addition. So what that means is that in addition, order actually doesn't matter. A plus 3 and 3 plus A are the same thing. They are equivalent. So let's take a look at an example. So let's say if we decided that the value of A was 4. Okay? So we're assigning A a value. We're saying that A can be replaced or substituted with the number 4. And so if I went ahead and put that in, so instead of A, I put 4. 4 plus 3 is 7. All right? And now let's look at my second expression. 3 plus A. So once again, I'm going to substitute in A with the number 4. That's the value I assigned it. And guess what? I also get 7. So even though these look a little bit different on the surface because the order is switched, if we plugged in the same number for A, we would get the same answer. Therefore, these are equivalent. Okay? So then we can cross out 1 and 10. So number 2, A plus A plus A. We'll put that in group 2. Okay? And let's look for any expressions that would go with it. Okay? So this is repeated addition. So it's the same number being added to itself multiple times. And at this point, we should all feel pretty confident that repeated addition is another way of doing or representing multiplication. So this is A times itself 3 times. So this is A times 3. Do I have that anywhere? So 4 is A times 3. Awesome. Now, do I have any other expressions that would say the same thing? This says the same thing. Once again, this is called next to notation. So anytime you have a number next to a variable, so once again, that number next to a variable is called the coefficient. That's actually just representing multiplication. And the last one that goes here is a little bit tricky. Yeah, I'll put it here. And that would be A divided by 1/3. So wait a second. Why am I putting a division problem with all these multiplication ones? Well, let's check. So once again, we're going to say a is 4. And we're going to do that substitution work again. So 4 plus 4 plus 4 equals 12. All right? So this one equals 12. So now all of these other ones should equal 12 if these 4 expressions are in fact equivalent. So let's see if that happens. So next one, a times 3. Once again, I'm going to substitute my value of 4 in for a, and 4 times 3 is in fact 12. Okay, awesome. So these both worked. Next one, 3a, 3, substituting in 4. And then when we substitute in with next to notation, we typically write that value in parentheses. That's another way of representing multiplication. And once again, 3 times 4 is 12. Okay? So all of those kind of expected. Now for that final one, that dividing fraction one, that's a little bit trickier. So once again, we are going to substitute in our value of 4, and then 4 divided by 1/3. So remember, so we're dividing by a fraction, which means we have to do keep, change, flip. Okay? And so I would keep the 4. I would change my division to multiplication, and I would do the reciprocal of this fraction. The reciprocal of 1/3, if I switch the numerator and denominator, would be 3 over 1, which is just 3. And so 4 times 3 is 12. So, once again, I plugged in a number for my variable, and in every case, I got the same answer. So these expressions are all equivalent. All right, so now we got a few more. So 3, a divided by 1/3. So we'll put this one in group 3. Or sorry, I just used that one. My bad. 1/3 a. Okay. So 1/3 times a. So this is not dividing by a fraction. This is multiplying by a fraction. And do any one of these other ones go with it? 1a, definitely not. So we could kind of assume that it's this one. Okay. So once again, we need to remember that fractions are division. So I'm not gonna make a in this situation 4. Well, you know what? Actually, I will. Why not? A equals 4. And so, if I plug in or substitute a for 4 and do 1/3 times a, or 1/3 times 4. So once again, we need to know when you multiply a whole number times a fraction, that whole number is going to multiply by the numerator, and I would get 4/3. All right. And now for the other one, a over 3, substitute 4 in for a, and I would get 4/3. So once again, same answer. Once again, this is why it's really helpful to begin writing division as fractions, because in this case where 4 cannot actually be divided by 3 evenly, then I can just leave my answer as 4 over 3 or 4/3, and that is an adequate answer. Okay, 4 divided by 3, or how many times does 3 fit into 4? 4/3 of a time. Or if you wanted to write it as a mixed number, this would be 1 1/3. Either way. And so the final one, that just leaves us with 8 and 9, and those are equivalent ones as well. 1 times a is the same thing as just having a. You plugged in 4 for a. 1 times 4, anything times 1 is itself. And if I substituted 4 in for this one, well, that's just 4. So, once again, equivalent expressions are expressions that would equal the same thing for any variable value. So if you substitute in a variable, they are equivalent if they give you the same answer. All right.